You know the feeling. You're staring at a whiteboard covered in equations, or maybe just trying to calculate the tip on a dinner bill, and your mind suddenly goes entirely blank. For generations, we've operated under the belief that mathematics is an artificial, rigid set of rules invented by ancient scholars, a subject where some people have the gene and others simply don't. Yet cognitive science shows that a 6-month-old infant who hasn't yet learned to speak will show visible surprise when a basic arithmetic sequence is presented incorrectly. They possess an intuitive understanding of quantity before they ever enter a classroom. This creates a paradox. If mathematics were merely an invented cultural tool, like the alphabet or traffic laws, the human brain shouldn't possess an instinct for it at birth. The human brain functions through a dedicated physical biological hardware specifically built for numerical processing. This number sense, or numerosity, is an evolutionary trait found across the entire animal kingdom. In the wild, arithmetic dictates survival. A predator encountering a rival group instinctively assesses the numerical size of the opposing pack, weighing the numbers before deciding whether to attack or retreat. Humans share this exact biological instinct, a neurological capability known as subitizing. This test illustrates the mechanism. When 3 dots flash on the screen, you know the quantity instantly. Your brain recognizes the number reflexively, the same way you recognize a color. But when a cluster of 7 dots appears, that instant recognition stops. Recognizing 1 to 3 objects is a hardwired reflex. To quantify anything beyond that small number, your brain is forced to switch tactics and engage a slower, more deliberate cognitive process. Grasping basic arithmetic is a foundational evolutionary survival reflex wired into our DNA, an instinct that existed long before the first classroom. If this number sense is a physical instinct, where exactly is it located? This model shows the specific anatomical region responsible for numerical processing, the parietal lobe. This region acts as the ancient biological hardware every human is born with. We treat formal mathematics, Arabic numerals, times tables, and complex formulas as societal software that we attempt to install onto not ancient hardware. Struggles with math typically indicate a compatibility issue, where the cultural software fails to align with how the biological hardware is built to work. Past difficulties with math are better understood as a translation error between modern education and ancient neuroanatomy. This leaves one final evolutionary puzzle. How does a brain originally built to count a handful of objects eventually manage to calculate quantum physics and orbital mechanics? To perform advanced math, the brain builds a network. Luminous neural pathways shoot out from the parietal lobe, connecting the number center to language and logic centers. This allows us to conceptualize abstract numbers that don't exist in nature, like 0, negatives, or infinity. Mathematics is the native tongue of your biology, even if it often feels like an alien language. This biological reality makes the identity of not a math person impossible to sustain. The next time you struggle with a complex equation, recognize what is happening. You are simply pushing a piece of beautifully engineered survival hardware to its absolute limits.